Now let me explain the third subdivision in the first problem, that is dividing the polynomial by another polynomial and finding the quotient and the remainder. Here the given polynomial, the divisor is x power 4 minus 5x plus 6 and g of x is 2 minus x square. So write the divisor x power 4 minus 5x plus 6 and this is dividend and the divisor is 2 minus x square. I am rearranging the terms in powers of x and writing it as minus x square plus 2. Now we already have minus x square, we should get x power 4. So minus into minus will become plus. X square when multiplied with the x square gives you x power 4. Then plus into minus minus, 2 multiplied with the x square gives you 2x square. Now we are subtracting the term, so it becomes minus x power 4 plus 2x power 2. So x power 4 gets cancelled. So we are going to write the remainder in leading powers of x. So we get 2x power 2 minus 5x plus 6. So we are going to check whether further division is possible. So yes, it is possible because here the leading power is 2. Here the divisor is also having the power 2. So we must make this minus x square as 2x square. So minus when multiplied with minus gives you plus. So we put minus here. So x square multiplied with 2 gives you 2x square. Then plus into minus minus, 2 multiplied with 2 gives you 4. So now on subtracting, 2x square gets cancelled. So we get minus 5x, 6 plus 4, 10. Further division is not possible because the remainder has a linear polynomial, that is a polynomial in powers of x as 1. But the divisor has the power 2, so further division is not possible. So the quotient is minus x square minus 2 and the remainder is minus 5x plus 10. Next problem number 2 is to check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. We are provided with two polynomials, that is t square minus 3 and the other biquadratic polynomial, that is 2t power 4 plus 3t cube minus 2t square minus 9t minus 12. We are going to divide the second polynomial by the first polynomial and we should check whether it is a factor. That means on dividing the second polynomial by the first polynomial, we should arrive at a remainder 0. If the remainder is 0, then we can surely tell that the second polynomial is divisible by the first polynomial. If not, it is not divisible. It is not a factor. So let us begin. So write the dividend inside 2t power 4 plus 3t cube minus 2t square minus 9t minus 12. And we have a divisor t square minus 3. So we must get 2t power 4. Here we have t square. T square when multiplied with t square gives you t power 4. And we have a coefficient 1 here. So 1 multiplied with 2 gives you 2. So t square when multiplied with 2t square gives you 2t power 4. The minus into plus minus 3 multiplied with 2t square gives you 6t square. On subtracting, 2t power 4 gets cancelled, so we get plus 3t power 3. Here one minus 2t square, here plus 6t square, so we get 4t square minus 9t minus 12. So further division is possible. So we have a t power 3 here. Here t square we have. So t square when multiplied with 3t gives you 3t power cube. Then minus into plus minus 3 multiplied with 3t gives you 9t. On subtracting 3t power 3 gets cancelled. So we have 4t square minus 9t plus 9t, that also get cancelled. minus 12. So further division, t square multiplied with 4 into t square, 4t square, minus into plus minus, 3 4s are 12. So minus 4t square plus 4t square will get cancelled. Minus 12 plus 12 also will get cancelled. So the remainder is 0. Since we are getting a remainder 0, this means 2t power 4 plus 3t cube minus 2t square minus 9t minus 12 is divisible by t square minus 3. That means the first polynomial is a factor of the second polynomial. If the remainder is not 0, if you are not arriving at a remainder 0, then we are sure that the given polynomial, first polynomial, is not a factor of the second one. Since we got 0, here we can tell that the first polynomial is the factor of the second polynomial.